Recording and action. Right, let's have a look at question 23. Got some special guests today. Sound off, please. Yes, very good, Jess. Yeah, I can vouch.
No. We're here, don't
They are here. Right, let's have a look at question 23. Question 23. Favourite topic of everybody's area under the curve. We're told A1 equals A2. Happy with that? Mm-hmm. Yes, A1 equals A2. We just now need to find, because these questions slightly different, because most of the time we're given, oh, that's probably not a good example.
Should have scrolled the other way.
I should have scrolled the other way, yes, I should have. Oh, God. Should have scrolled the other way, Jess. Most of the time we're given our limits of integration. We're told from here to here is our, there we go. So we're told measure from there to there. So in our question up here, we're actually trying to find those endpoints and we're given information about the area. So we've kind of got the answer. We know the area under the curve, which is 1, the curve is 1 over x. So we're told this, just crank it out of it. Oh, yeah. You're told here's area 1 and it runs between 1 and A, and here's area 2 that runs between 1 and B. So I've sort of broken out as two parts. There's area 1, there's area 2. So all now we do is to integrate 1 on x, that's log x. Integrate 1 on x, that's log x. The same, I've just sort of skipped that part there. So here we're told the top boundary was 1, the lower boundary is A. This one, our top boundary was B, our lower boundary is 1. So putting that into our integrated step here, log 1 minus log A equals 1. And same on this side. Now paying attention to just simply solving these, I've got, what does log 1 equal? That equals 0, just chucking the calculator. Have a look, that's equals 0. So you've got minus log A here equals 1. Remember you can do the powers of thing or type it in a calculator, whatever you like to figure this one out. You're happy with this? How do you solve this? How do you get rid of the log? How do you get rid of logs? Do you remember that? E. So if you take the power of E, and also I didn't like the minus one here, so I've moved it to the other side. So I've just got E to the log A, which cancels the E and log A bit out. So I've just got A equals E to the minus 1. And on the other side, same deal, because I've got these limits of integration. I've got log B minus log 1. We just said that equals 0. So I've got log B equals 1. Same deal, E to the powers of. And I've got B equals E. So that's pretty straightforward and a nice 3 marker.
That's not too bad.
No, it was pretty doable. This question here, this one pretty serious. And we haven't really looked at using dy yet, as this question turns out. We use chunks of dy. Because if we have a look here, you just think, oh yeah, I've done these before. We do a dx. And this is what I've done here. But if you have a look at your notes and stuff, we haven't really done integration of logs before. You may think, oh, haven't done integration of a log. Maybe it's 1 on x. And this is all my scribbles and dribbles to try and work it out as a dx. And you know what? It didn't work. It didn't work. And this is me sort of thinking like, you guys going, oh, how am I going to do this? So the alternative to that is, because I want that bit, recognising that this is one giant rectangle would mean that if I could find this area minus that out of the rectangle, I'd be left with that bit. So that's what we've sort of done. And we haven't really done a lot of these questions with dy, so we'll have a bit of a look at that. So ignoring, where'd that go? Ignoring all that stuff through here, that's figuring out I can't do integration with logs. I've said, well, let's have a crack at doing it using dy. So remember, how wide is this strip? It's dy. And remember, going back to really right at the start of integration, the idea of integration is we want the area of this rectangle, and we're going to add up heaps of them all the way down the page or across the page. Well, this is saying it's really thin strip, so I want that line, I want that one, that one, that one. That's what the whole integration sign means. We're going to add up all these little strips. So I'm going to start at log y, and we're going to add up all these little strips all the way down to 0. And how wide is my rectangle? It is xy, and it is dy tall. Hello, sir.
Yeah.
Good. You joining in?
One really quick question that you can finish.
there a pause button?
There is a pause button. You will make it or something.
Yeah. All right, we're back. We've had a little pause and we're back, hey?
We'll just send them both.
Oh, yeah, true. All right, I'm looking at do y. So we said Dex didn't work because we couldn't integrate logs. Let's try it downwards. So we've got our function. So this is now x y times by y. This, what does all this say? This says add up, like the big S, add up the sum of x times dy. So add up that rectangle from the top down to the bottom. The only issue, of course, is that we're talking dy's and this letter is x. So we can't just integrate blindly. We've got to have s as an x or change that to a y. So that's what we're going to do. We know y equals log. We're told all this stuff, but we can rearrange it. So this is written as a y. So if we had y dy's, we can integrate. So I'm going to change this x to be just as a y. So whatever is rewritten as a y. So I knew this statement here. Again, how do I change to get my x by itself? I'll do e to the y, e to the y. So e to the y is e to the log, so the e and log will cancel out. So I'll just leave x minus 2. Chuck the 2 to the other side. Now I've got x by itself. X by itself is e to the y plus 2. I'm going to just put that in there. So I'm going to replace the x with stuff just in terms of y. Now my area is the log y, the dot bit down to the bottom bit. So there's the limits, top bit to bottom bit, all in terms of y dy. So integrating that, what's the integral of e to the y? E to the y, that's pretty straightforward. Integral of 2 is 2y. So that's a fairly straightforward integral. Putting in this information, e to the log 5, e and the log would cancel out, so that's just 5, times plus 2 lots of the logs. Being careful, because we see 0. I don't know if you've seen 0 a lot and you just make it 0 straight away. So just pay attention. Remember e to the naught. What's e to the naught? 1. So remembering e to the naught didn't turn to 0, it stays as 1. So now I have got this scenario. I've got all this area here. Is that number there? Where the hell that is? And going back to our original question was, I want that bit. So if I know that chunky piece is there, how big is the full rectangle? The full rectangle is log 5 high, 7 wide. I don't know where we got the 7 from. Is that given up here somewhere? I assume. Yeah, there you go. So it is 7 wide. It is log 5 high. And so I'm just going to do that bit, the big rectangle minus off 7 log 5, minus off the bit I found before. And just do a bit of calculation there. Can you do this stuff? So 7 log 5 minus the 4 minus 2 log 5s. 7 log 5 minus 2 log 5s is 5 log 5. 5 log 5, take it for 4. Yep. Yeah, but again, do these questions yourself. I've figured out how to convert this page to a PDF, so I'll attach it to the documents.
Good.
Rather
They're the
than-
easiest to use.
Yeah. All right, adios.
And